Okay, so we're recording. So again, we're focused on week 5, even though we're in week 4 right now, on 7.1 on waves. So when you think of waves, obviously you think of like the ocean or sound, but something that kind of looks like this, right? It's basically a traveling disturbance. And sometimes it can be very disturbing, or you might think of turbulence, like when you're on an airplane, you experience turbulence. Well, you're flying through the air. Air has waves, and that's going to impact the motion of an airplane. Fortunately, the airplane's going to be fine. You're not going to crash, but scary at the same time, too, if you have a fear of flying. Or if you're on a boat and the waters are really choppy, that's heavy disturbance, too. So it does carry energy, just so you know. So when a boat makes a wave, the water itself does not get up and move, of course, but the water pushes a little and then moves back. So the energy is transferred in the wave and is what you feel. Now, there are two types of waves to talk about, transverse and longitudinal. Transverse are the ones that kind of go up and down. Or it's an up and down disturbance, I guess. So the direction, so waves travel left or right. And disturbance is going to be perpendicular to the direction of travel. So I'll give you some examples here. Radio waves, light. And I'll draw a picture for you guys because I think it'll help. Microwaves, stringed instruments. So let's say you have like a wall here. You have a piece of string. So the motion of the wave so the wave travels horizontally, of course, right? But we examine the way its vertical changes. Basically, its amplitude is what we're interested in. So that's kind of how radio waves and light waves kind of travel. Now, longitudinal waves, the disturbance is now left and right. And the direction of travel is still left or right. So as you can imagine, the disturbance and direction of travel are now parallel together. There are a series of compressed and stretched regions. Examples would be kind of like a sound wave. Another good example would be when you're dealing with a spring, which I think we'll talk about tomorrow, but like here's a spring, and what's going to happen is that you can coil or recoil, so you can kind of push the string in or push it out. Like if you push the spring in, or pull the spring, and it kind of bounces back and forth. The bouncing motion is what we analyze. So that's kind of an example of longitudinal wave. Because it's not kind of like going like this, right? It's kind of going like this. And that's the motion, that's how it travels as well. And sound kind of does that same thing. There are some waves that do a combination of the two. We're not going to really examine those. But there are waves that are a combination. Water, the surface of water wave travels in small circles, for example. But we're not going to get into that. Now, this stuff I care a lot about because we do have to break down the composition of a wave. And if you've had pre-calculus or if you've had altitude trig honors, then this should be kind of review. But if you haven't, it's not that hard. It's pretty easy. So the wavelength, well, first of all, let's talk about what periodic means. Periodic means the pattern is regularly repeated, so regular. It happens with some consistency. So it's kind of like, for example, let's say you start a stopwatch at 0 seconds and 10 seconds to get to this point. Then I know I get to this point in 20 seconds. I'm always kind of getting back to that same place and heading in the upward direction if the wave does this. So it's kind of a consistency. The cycle is basically 1 unit of a pattern. So this right here is considered 1 cycle because then it repeats itself. The wavelength is the distance of 1 cycle. Again, it's 1 unit of the pattern. Let me erase that and make that neater. Again, distance. And the amplitude is height from equilibrium to crest. So the crest is the top, and equilibrium is kind of like the middle. So that's considered the amplitude. And then the period is the time it takes to complete 1 cycle. So like, for example, I put 0 seconds here and 10 seconds here, so my period would be 10 seconds. You can think of like in basketball, basketball has 4 periods. In NBA, they do 4 quarters of 4 periods, 12 minutes each. Or hockey, they do 3 periods, 20 minutes each, right? Football, they don't really call them periods, but they're 15-minute quarters. You kind of get the point. So that's repetitive and regular. And we tend to use seconds. And of course, well, I shouldn't say of course. The frequency is the number of cycles per second. Like how often do you expect this cycle to repeat? So say, for example, actually, I'll just get rid of that one right there. Say this is 0 seconds. Say it's 0.5 seconds. And say it's 1 second. Clearly, I'm doing 2 cycles in 1 second, so my frequency would be 2. It is the reciprocal of the period. And the units for a frequency is the reciprocal of seconds, or 1/s. We also call that a hertz. So hertz is seconds to the -1 power, just so you know. Velocity of a wave is your wavelength. And we use, I forgot to label this. We call this lambda. It's a Greek alphabet. And that's distance in meters. And if you divide by time, your period, of course, that's meters per second. Or you could, if you want, do your frequency, which is 1/seconds times wavelength. That works also. So the velocity of a wave could be wavelength over a period. That's how fast the wave is moving. Or it could be your frequency times your wavelength. So the formulas are pretty straightforward, pretty simple. It's very visual still. So let me clear. Let's do a couple problems. I'll have you guys go in breakout rooms and try some on your own. So WAUS, I don't know what that is, but mega radio station, operates frequency 90.7 MHz. Now M stands for mega. So basically it's 90.7 times 10 to the 6th power seconds to -1. That's the units we use for hertz, is seconds to -1 power. And you're given the velocity is 2.99 times 10 to the 8. That's actually the speed of light. So I thought it was kind of, maybe this is something with light, I don't know. Anyway, I'm not gonna really get too concerned about that. They want the wavelength of the period. So remember, your velocity is gonna be your lambda over time, or your velocity could be your frequency times your wavelength. So remember, our velocity is 2.99 times 10 to the 8th. Our frequency, of course, is 90.7 times 10 to the 6th. And times lambda. So if I solve for lambda correctly, I'm going to divide everything by that junk. And you'll need a calculator, of course. I know these will cancel. So it comes 10 squared. So I'm doing 2.99 divided by 90.7. Hold on a sec here. So I think you get about 3.297. If I did that correctly, I think that's right. Yeah, because then I got times up by 100 meters. Excuse me. And then get the period. You do 2.99 times 10 to the 8th equals 3.297 over capital T. You'll have to do a little maneuvering. It's gonna be super, super small. That's because it's happening very quickly, you know. So it's 1.10 times 10 to the -8 seconds. And again, just use a calculator for that one. So that's that example. Then we have just one more. You're sitting on the beach and notice the seagull floating on the water, moves up and down 15 times in 1 minute. What is the frequency of the water wave? So remember, it's your cycle, so it moves up and down. So basically, here's the water. Actually, let's do blue. It's a little bit better for water. There's a bird. It moves up and down. Not a good looking bird, but 15 times in 1 minute. So basically then it's the number of cycles. Remember, frequency and there's a number of cycles per second. So you have 15 cycles happening in 60 seconds. So you're doing for 1 minute. So the frequency is 0.25 hertz. So that's all you got there. So problem should be pretty straightforward, hopefully. Just trying to think here if anything else I need to kind of say. So let's actually have you guys try 6 through 15. So if we see, we can just knock all this out before our lunch break. So we'll do our lunch break around 11:30ish. I'll give you guys 15 minutes. And I'll hop into breakout rooms if you guys are stuck. So don't worry about the first 4 questions, but let's just do 5 through 15. So it's 11 problems in 15 minutes, and the answers are right there. Actually, I'll do 5 with you guys right now. 60 hertz, so remember that's 60. Remember, period's going to be frequency is 1 over t, or t equals 1 over f. So doing 1 over 60, which is 0.0167 seconds. So you can leave it like that, that's totally fine. But you put milliseconds because they're moving the decimal point 3 places to the right. So that's why you get 16.7 milliseconds. Remember what milli means. So I already did 5 for you guys. I'll have you guys do 6 through 15 in your groups. So stop the recording.